we are considering landscape formation. Mm, Introduction. The Earth's surface is young in geological terms, mostly less than 1000 million years old. The surface age indicates a geologically active planet with evidence of the intense bombardment period of the early solar system having been largely obscured by a crustal deformation, volcanic activity, erosion, and deposition. The large-scale features of the Earth's surface, such as mountain ranges, rift valleys, and ocean trenches, are controlled by the continuing motion of sections of the crust. This process, termed uh, template tectonics, seems to be unique to Earth among the terrestrial planets in the present day. Another striking feature of the Earth's surface is the abundance of water, evidenced not just by the extensive oceans, but by the water erosion features which have shaped the land. Much of the continental land masses are covered by the uh, regolith of weathered debris, soils, mud, sands, and loose rocks, which provides a foothold for most of the planet's life forms. Physical regions. Physical regions describe the large area which has some overriding physical characteristics. For example, it is low-lying or forms a basin. Other physical regions include plains, plateaus, canyons, and they are okay, and can therefore encompass a wide variety of different terrain. The physical regions may be given a distinct character by a geological process at work, like Badlands of South Dakota. Its pinnacles and gullies is sculpted by the water supplied by violent thunderstorms. The semi-arid badlands lack vegetation to bind the soil and protect the weak sedimentary rocks from the torrential downpours. The cold and arid Tibetan plateau is distinct physical region. Other physical regions are created by geological process on much larger scale. The Deccan, for instance, is the southern and triangular shaped peninsula of India. It's a high tableland with an average elevation of 600 meters. It slopes gently eastward but is bounded to both the east and west by hills. Western and eastern Ghats. Physical regions very often have climatic characteristics which also set them apart from their surroundings. The Deccan is no exception. The plateau is far more arid than the surrounding coastal strip. Here the Saudi Arabia vast interior is called Rab al-Khali, the empty quarter. The term physical region is also a useful way of describing large desolate regions like drowning mountain in Antarctica or Rab al-Khali, the empty quarter of the Arabian Peninsula. Mountain ranges. A mountain range is a series of or chain of mountains. Although volcanic activity can produce a mountain in isolation, most mountains occur in ranges. The world's largest mountain ranges themselves belong to two enormous belt systems. The Circum-Pacific system includes Rockies and Andes. The Himalayan or Tethyan system incorporates the Himalayas and mountains of the Middle East. The Rocky Mountains, this part of the chain in Canada. Towards the left of the picture, running a northwest direction out of the frame, is the Columbia River. The ranges are formed by folding, faulting, and warping of the earth crust and by volcanic activity. The most impressive mountain chains are created near the margins of tectonic plates. The Himalayas, which of course have many of highest peaks in the planet, are produced by Indo-European plate, which incorporates India, pushing into Eurasian plate Asia. As it does so, the Eurasian plate is compressed and is pushed upward. The Swiss Alps were raised by a similar crumping effect as the African plate pushed northward against the southwest edge of the Eurasian plate. Some of the world's longest chains are formed at destructive plate margins. One of the best examples is where the edge of the Pacific plate disappeared underneath the South American plate along the Peruvian and Chilean coast. The descending plate forms a deep trench, the Peru-Chile trench, and when it enters into the Earth's molten asthenosphere itself is melted. The thickening crust here forms the Andes mountain chain. At some destructive margins along the west coast of the North America and the east coast of Japan, magma from the melted subducted plates arises through the crust to form a range of volcanic mountains parallel with the edge of the plate. These mountains also steep-sided volcanic cones. Ranges can also be formed when fractured crustal blocks are tilted or when the Earth's crust is upturned, bent upwards without fracturing, forming dome mountains like Black Hills of South Dakota. Mountains. A mountain is an area of the ground much higher than its surrounding with a narrow peak compared to its base. A hill becomes a mountain if it's measured more than 1000 feet, about 300 meters from the root on the foot to summit. Mountain ranges show where the Earth's crust has been compressed and thickened by the movement of the tectonic plates. Older, heavily eroded mountains can be found in the middle of the continents, at the site of the tectonic activity in the distant past. The Rocky Mountains were formed as the North American continent accumulated a series of fragments moving from the west. The Urals show where the Europe and western Siberia collided 220 million years ago. Younger and higher mountains are found where tectonic plates are meeting today, such as Himalayas, which lie on the junction of the Indian and Eurasian plates. Here the Alps and Jura mountains covered by snow in March 2000. Here the Picos de Europa in northern Spain rise more than 2,500 meters, 6,825 feet. In mountain building episodes, compressive forces cause the crust to buckle, often leaving a parallel folds of rock or complex jumble where layers of rock have been thrust over another. Here the Appalachian Fall Mountains cut by the Susquehanna River in the Pennsylvania. Erosion by ice and water wears down the elevated surface, leaving high peaks separated by steep valleys. In the Appalachian Mountains of America East Coast, old folded rock layers have been exposed and the more resistant layers appeared as parallel ridges. The summit of Mount Rainier, Washington State, 4,392 meters, 11,990 feet. Like many high mountains, is stopped by a permanent glacier. Is stopped by the permanent glacier. The mountain building can be due to volcanic activity as well as compression, with repeated eruptions of lava and ash able to build the cones of high volcanoes. In the coast ranges of western North America, the chain of volcanoes run the length of the subduction zone, where the Juan de Fuca plate is shrinking beneath the North American plate. Similar chains of volcanoes are found in South America, Alaska, and Japan, circling the Pacific with the Ring of Fire. Volcanic features are found at the tectonic plate boundaries and in hot spots within continents or ocean basins. Volcanoes have built up where molten rock or magma from Earth interior erupts to the surface. 18% of Earth's erupted magma is the basaltic lava. Basaltic lava found elsewhere in the solar system. Basalt is also a major component of the crust in the ocean basins. Basaltic lava has low silica content and is comparatively fluid, flowing a long way before solidifying and thus producing broad-based shield volcanoes and even thick horizontal sheets called lava latex. Andesite and rhyolite are lavas with increasing proportions of silica, making them stiffer, more viscous than basalt. They don't flow so far, producing volcanoes with steeper slopes. When dissolved gases are present in magma, pressure changes cause the gas to escape as the magma reaches the surface. In stiffer lava, the expanding gas can be trapped until it escapes explosively. This can produce the airborne material or tephra that, with sizes varying from volcanic bombs several centimeters across to fine ash. Ash from the large explosive eruptions, can rise tens of kilometers into the atmosphere and spread thousands of kilometers horizontally and is easily seen from space. Here, 1994 eruption of Yuklyu-Chevskaya in Kamchatka Peninsula. Tetrachon build up around the vents of explosive rhyolitic and andesitic volcanoes as the debris showers down, producing steep slopes of loose materials. The highest volcanoes are stratovolcanoes, which emit both viscous lava, usually andesite, and tephra. The lava layers act to protect the tephra layers from erosion, allowing the volcano to build much higher than a simple tephra cone. Here the Mount Helens exploded in 1980, devastating the previously forested landscape. Volcanoes can be recognized from Earth orbit by their circular form, often with a sizable eruption crater at the summit. Extinct or dormant volcanoes can be heavily eroded with the radial drainage pattern. Large volcanoes may show a sizable collapse crater or caldera where an empty magma chamber has collapsed, such as Ngorongoro in Tanzania. Here, Ngorongoro crater, East Africa, is a caldera left after a huge eruption 3 million years ago. There are some correlation between the explosion of the composition of lava and its composition of tectonic plate. Andesitic stratovolcanoes occur at the continental margins where oceanic crust is subducted under continental crust. Rhyolitic magma is erupted mainly from continental crust. Basaltic lava is extruded all along the mid-ocean ridges, and basaltic shield volcanoes are found in the ocean basins. Basaltic lava is also erupted through the continental crust, however, indicating an origin in the mantle beneath both types of crust. Igneous rocks do not always make it to the surface before solidifying. Subsequent erosion, however, may expose them to view. Large igneous intrusions into the crust may uplift an overlying rock strata. Batholiths are large intrusions up to 15 kilometers thick. Sills and dikes are thinner intrusions along weaknesses in the surrounding rock. Sills are sheets up to 300 meters thick, running between rocks bedding planes, while the dikes run through fractures across the bedding planes. Laccoliths are mushroom-shaped intrusions between bedding planes, which have caused the overlying strata to dome upwards. Escarpments. An escarpment is an land cliff. Escarpments are steep slopes, often vertical, with border plateaus and or uplands. Escarpments or scarps, as they are also known, can be formed by faulting, as blocks of Earth's crust are tiled or shear, or simply by erosion, as rivers cut through soft layers of rock to form a valley with walls like Arizona's Grand Canyon. Here the spaceborne radar image of Pang Hoi Range in Southeast Asia. Its plateaus feature steep scarps. Escarpments are the steep slopes of buttes and mesas too. These are formed where a hard layer of rock like basalt, a fine-grained volcanic rock, overlies a soft layer, where the basalt occurs perhaps in a wide strip emplaced by a flow of lava. The soft rock is protected, but the basalt is absent. The erosion by wind and water can wear down the rock, leaving a steep sided plateau. The steep slopes surrounding desert plateau in Mauritania, West Africa. Escarpments can be local or regional features like the buttes and mesas of the American Midwest or continental in scale like Africa's Great Escarpment. The Great Escarpment forms the southern border of South Africa's large interior upland, at the base of which lies the narrow strip of coastline. It extends southeast from Namibia and Angola through the South Africa, along the north edge of the Groot Karo Plateau, and runs northeast along the Lesotho border through the Drakensberg Mountains and into Zimbabwe. In the Drakensberg Mountains, the Great Escarpment is a result of hard volcanic rock overlying soft sandstone shelves where the scarp is formed by rapid down-cutting actions of rivers' headwaters. Valleys are created as a result of water or ice erosion cut by rivers or glaciers as they moved downhill or by rifting along fault lines. Glacier cut valleys are distinguished by their broad U-shaped profile with steep sides and flat bottoms. Many areas which the ice-free today contains glacial valleys gouge out during the last ice age, which peaked 20,000 years ago. In Europe, the Alps and the Pyrenees and Atlantic Highlands of Scotland and Norway are dominated by glacial valleys, many of them containing long lakes damped by glacier debris. Here the glacier cut U-shaped valley in the Lake District of northern England. The river cut valleys in mountain areas are narrower with V-shaped profile. The water flow wears away the soil and bedrock of the valley, and loose materials is carried downstream itself, contributing to the erosion of the riverbed and banks. The river cut V-shaped valleys in Atlas Mountains of Morocco. Canyons or gorges are very long, deep valleys with steep walls, usually formed in arid regions where there is a little rainfall to wash away the slopes, or where the rock is particularly weak, such as limestone regions. The Grand Canyon in the southern USA started to form when the mature meandering Colorado River was uplifted, increasing its erosive power. The Grand Canyon has gouged out from 1600 meter thick sediment. A rift valley is formed when the land drops between two parallel faults as a result of tectonic movement. Central section of the river Rhine flows through the rift valley, and the Great East African Rift Valley shows where the Somali plate is starting to split away from the main African plate. The broad valleys of the Basin and Range province of the western USA is the result of a series of half rift due to east-west stretching of the crust. Here the Chaos Gorge in northern Spain was formed by first by a glacier action and then by a river erosion down through the salt limestone rock. Impact craters. Complete regeneration of Earth's surface has obliterated traces of meteorite impacts from the inner solar system's heavy bombardment period more than 4,000 million years ago. Many of the 200 known impact sites around the world are in the oldest stable continental rocks or craters dating back more than 500 million years. However, impact continue at a low rate to this day. Major geographical features features thought to have originated as meteorite impact basins include Chesapeake Bay, the Central European Depression, roughly corresponding to the extent of the Czech Republic, and the part of Hudson Bay. These large old impacts have been deformed by the subsequent movement of the Earth crust and flooded by the sea level changes. Here the Manicouagan, the impact crater remnant in the ancient Canadian Shield. Craters on Earth's smaller impacts include Manicouagan Cubic, 212 million years old, and the Gossas Bluff, Australia. One of the most recent and best preserved impact sites is Meteorite Crater, Arizona, 50,000 years old. Meteorite impact craters have a number of distinguishing features which can be detected from this space. A circular shape, uplifted and overturned rock strata at the rim for larger structures, and the central uplifted peak or ring of concentric hills for the larger structures. Anomalies in the local gravity and magnetic fields. Here the Meteorite Crater, Arizona, with the raised crater rim and bright injector topet. Around 65 million years ago, a very large body is thought to have impacted the Earth on the Yucatan Peninsula in Central America. The body, believed to have been an asteroid or comet, may have sent through impact debris into the atmosphere to impede photosynthesis in plant life. The timing of the impact coincidence with the mass extinction of 2/3 of the planet's animal species, including the dinosaurs, suggesting that the large impacts can be a global catastrophe. It is precisely because a large impact might have devastating global consequences for life that a monitoring or tracking program has been established to detect any asteroids that may be a collision course with Earth. Many asteroids already cross Earth's orbit and are known as near-Earth asteroid (NEAs). The impressions of the three meteorite impacts at Oronga, North Africa. Over the last century, impacts of sizable bodies have been reported in Tunguska, Siberia, in South America, and in Arabian Peninsula. The rate of crater formation in the solar system today is far lower than during the formation of the planets, but the collision do still occur. Many meteorites enter the Earth's atmosphere every day, but the vast majority burn up due to friction. Few that survive the heat hit the ground many not even forming a crater. Over 3,000 meteorite falls are known so far, with about 10,000 meteorite pieces recovered. Earthquakes are caused by a relief of stress buildup along the faults in the rocks of the earth crust. A fault may produce a frequent small slips or may store up energy like an elastic band until the large movement occurs. The movement produces a shock in the rock, and waves of compression travel in the directions from the location of the movement. The focus, usually some may underground. These waves are referred to as body waves, since they move through the body of the rock. When these waves reach the surface can be disturbed, producing surface waves, the slower moving disturbances which cause most destruction. The point of the surface vertically above the focus is referred to as the epicenter, and it is here that the surface disturbance is usually greatest. Compressional body waves travel at about 6 kilometers per second in the upper portions of the crust, producing a backward and forward shaking in the direction of their travel. Shear body waves are also produced, typically traveling at 3.5 kilometers per second, resulting in a sideways movement perpendicular to the direction of travel. Since the compressional waves always arrived first, they are referred to as primary or P waves, and the shear waves are called secondary or S waves. The last to arrive at the damaging surface waves, which movement up and down. Sensitive seismic recording equipment can detect and distinguish P and S waves from very distant earthquakes, making it possible by comparing the timings from the widely separated sites to pinpoint the epicenter and depth. Much of our knowledge about the interior structure of the earth is also inferred from the analysis of seismic signals produced by earthquakes. Energy released by a large earthquake can be similar to that produced by the large nuclear bomb. It is possible to measure the elastic energy stored in rocks before and after the earthquake, and thus find out how much energy was released, but in practice this is very difficult to do. Instead, the energy released is estimated by measuring the maximum amplitude of the P waves and duration of wave cycle and the time delay between the arrival of P and S waves. The scale measurement is called the Richter magnitude scale after seismologist who developed the method. The Richter scale is logarithmic, so that an increase of 1 unit corresponds to a tenfold increase in the amplitude. This would normally equate to a 100-fold increase in energy, but larger quakes tend to produce longer wavelength, reducing the average energy increase to 30 times. The difference between a magnitude 4 and magnitude 7 event is thus 30 multiplied by 30 multiplied by 30, 27 times more energy. A magnitude 4.5 event is rough to the rattle window frames, but the magnitude 7 event will cause bridges to twist and masonry buildings to collapse. Quakes above magnitude 8.0 occur once every 5 to 10 years and are totally destructive. The largest recorded Richter magnitudes to date is about 8.6, corresponding to the 10,000 bombs of the size dropped on Hiroshima in 1925. Luckily, these events were in sparsely populated areas. Highland and plateau. A plateau is an extensive, mainly leveled area of high ground. The ground may have been recently uplifted and be cut by steep canyons, as with the Colorado Plateau in the southwest USA. An older plateau may have broader valleys separating areas of high ground called mesas. Later, still only small remnant of the original surface called buttes may remain on the eroded plain. Buttes in the Monument Valley, Arizona. Ethiopian highlands are plateaus lying either side of the Great Rift Valley in East Africa. Intermontane plateaux are completely and almost completely surrounded by mountains, as with the Tibetan Plateau. The Tibetan Plateau rises over 5,000 meters, 13 and 650 feet above the sea level. A Piedmont Plateau, such as Patagonia in South America, lies between mountains area and the plain or ocean. A continental plateau, or tableland such as Karoo of South Africa rises abruptly from lowlands or the sea. Here the dry plateau of Karoo, South Africa. Plains, as the river approaches the sea level, a slope or flow lessens and the river starts to drop its load of eroded materials as sediment. Broad flat plains can be created as a sediment from large river and its tributaries build up. Periodic floods deposit sediments some distance from the river itself, forming a floodplain. Sediment can change the course of river with the mature rivers in lowland areas such as Mississippi, forming looping channels called meanders. Extreme meanders can meet at the neck, allowing the river to flow straight again and leaving behind the Oxbow Lake. The largest river basins, the Amazon in South America and Congo in Africa, are very flat, leading to multi-braided river channels. The Mississippi River floodplain shows meanders and Oxbow Lakes near Memphis, Tennessee. At the cost of the volume of sediment deposited can be very large, and some rivers have extended large deltas into the coastal sea waters. The Nile splits into very into very many streams as it flows over its delta and into the Mediterranean. In contrast, the Mississippi has built up crow's foot delta with one main channel which has shifted around over thousands of years. The delta of river Indus glints in the morning sun. Deserts. The desert landscape is dominated by the lack of the rainfall and therefore vegetation. The soil is dry sand and easily blown around by the wind, accumulating its depressions at sand seas or ergs such as the erg Chech in Sahara and empty quarter Rab al Khali in Saudi Arabia. Here the scattered sediments flank the river Dra on the edge of Sahara Desert. Sand dunes can reach several hundred meters, around 900 feet in height, and can be several kilometers, around 4 miles across, big enough to appear in the 1 kilometer satellite imagery used to use this atlas. Areas of higher ground left covered only by stones and gravel are called Hamada. Examples include Hamada Dra in the Western Sahara and the Syrian desert. Here the desert ground blown clear of sand called Hamada. Windborne sand is strong erosive force, although occasional rains cause flash floods which can carve out drainage channels, steep gullies on the slopes of hills and mountains, and broader shallow drainage channels in low areas. These channels, called wadis in Sahara and Arabia, are dry for most at the time and usually peter out into the desert sands. A dry riverbed in the Atlas Mountains in North Africa, where adjacent mountains induce rainfall. Water courses may drain into lake where the water becomes saline due to high evaporation rate. Lake Van in Turkey is one of such salt lake, as is the Great Salt Lake in Utah, USA. The Bonneville Flats to the west is a seasonal lake which floods occasionally but is usually salt flat. The largest salt flat or playa is the Sala de Uyuni in Andean Altiplano. Oasis. Although some major rivers such as Nile cross desert areas, bringing a permanent supply of fresh water, most life must rely on the groundwater, which occasionally near the surface of an oasis. On the south side of Taklamakan Desert, in western China, a series of large oases occurs at the basis of the Kunlun Shan Mountains, where the groundwater is focused to the surface by a change in rock type. Here, the large oasis at the foot of the Kunlun Shan were stops in the ancient trade routes of the Silk Road. Rivers. Rivers, when the ground becomes saturated with water, surface runoff results with the water flowing over the earth's rocks and regolith. Stream networks result providing conduit for the water and mechanism for erosion of the landscape. Weathered rock debris is transported in the stream flow, scoring out deep V-shaped channels in the fast moving streams in upland areas. Erosion rates are greatest in the high upland areas where the rivers quickly transport sediment to the lower altitudes. The Himalayan mountains and Tibetan plateau, comprising 5% of the land surface, is the source of 25% of the sediment input to the world's oceans. Yeah, the Brahmaputra River creates a floodplain in the broad Wassam Valley, one of the wettest places on earth. Fraser River is deposited a large sedimentary delta in the Pacific coast of North America. In lower land, where the stream flow is reduced, some of the sediment load is deposited, perhaps blocking the river and changing its course, producing features such as alluvial fans at the base of cliffs, meanders, and oxbow lakes on the floodplains, and braided channels within the river bed itself. Here the Mississippi River with oxbow lakes, evidence of its former stream channels. The river Congo splits into many streams as it flows across its very flat basin. When lowland with a mature meandering river is uplifted, the river flows faster due to its increased gravitational potential energy and can start to cut down once again. The Grand Canyon in North America is an example of such rejuvenated river containing many incised meanders which have cut 1600 meters down through the underlying rock strata. Lakes form in local topographic lows, perhaps formed by glacial scourging, rocky debris, or sedimentation. So, circular crater lakes occur in the eruption craters or calderas of volcanic usually extinct or in meteorite impact craters. Lake in Andes Mountains, colored by eroded rock in the meltwater of the glaciers that feed it. Most lakes have an outflow river which continues to flow down to the sea level. In arid areas, a large portion of the lake's water may be lost by evaporation and there may be no outflow. In such lakes may be seasonal, filling up during the rainy times and leaving the salt residue behind after the water has evaporated. Lake in Andes Mountains, colored by eroded rock in the meltwater of the glaciers that feed it. A chaotic drainage system of rivers and lakes in Asia's Changjiang River Basin. Cooper Creek, Australia, a large outwash plain subject to flash floods in an arid area. Oceans. Oceans over 77% of the Earth's surface and give blue planet its dominant color. Sediments accumulate at the edges of the continents in the continental shelf and around mid-ocean islands, brought to the ocean by river waters. The continental shelf of the Atlantic coast of North America consists of pile of sediment several kilometers thick, topped by 3 meters of sand, which continue to be moved around by ocean tides and currents. Tides are caused by gravitational attraction of the moon. Surface currents are largely driven by pressure and wind systems in the atmosphere above. Here the mud and sandbanks are exposed at low tide in the Frisian Island. Wave action can shift coastal sediment into sandbars and spits. Large slumps of sand or mud can give a rise to turbidly currents which move very fast down slight slopes due to the increased density of water containing suspended materials. Deep gullies and canyons have been eroded on the sand bed, particularly in the continental shelf sediments. Here, the deep canyon in the continental shelf of Monterey Bay, California. Sediments also accumulate right across the ocean basins from the chemical decomposition of dissolved minerals. The calcium carbonate shells of Dead Sea creatures sink and accumulate as oozes on the deep sea ocean floor. In contrast, the canyons of continental shelf, the deep ocean floors are fattest places on the planet. The mid-ocean ridges are where new earth crust is created by uh, extrusion of lava at tectonic plate boundaries. Like at the atmosphere, the oceans are responsible for heat flow from the equatorial regions to the poles. This spreads energy from sun over the surface to the planet, evening out the extremes of climate. Similar to the Hadley circulation cells in the atmosphere, a global circulation system has been suggested for oceans whereby ocean waters are carried poleward at the surface and returned as cold, dense water in the ocean depths. This great ocean conveyor belt, with the turnover period of more than 1000 years, is a key part of the global climate system. Unlike atmosphere ocean circulation, it is restricted to the position of the continental land masses, with exchanges of water between ocean basins are quite limited. The global sea surface temperature over a 10-day period Some ocean life forms centrate calcium carbonate shells to protect themselves as they move through the water. Others anchor themselves to rocks in shallow seas, leaving behind their skeleton calcium carbonate as a coral reef structure when they die. Coral reefs are found on carbonate platforms in shallow water on the continental shelf and in mid-ocean. Mid-ocean coral reefs initially grow in the shallow water around the volcanic island. As volcanic activity ceases, the island starts to erode and subside, but the coral colonies continue to grow if they stay within sunlit top 20 meters 37 feet of ocean. In this way, circular atolls are formed, the great thickness of limestone above the sites of extinct volcanoes. Here the Pearl and Hermes atoll, part of the Hawaiian chain in the Pacific. Here the Maldive Islands, a string of more than 2,000 coral coral formations. Gulfs, usually a larger and more enclosed than a bay, which tend to be formed by erosion over time, producing a gentle curved coastline. A gulf is a deep indentation. Here the northern end of the Gulf California, in Mexico, seen from the space shuttle Endeavour. Body of the water at the top of the image is the Salton Sea in the USA. A gulf can be created by flooding a low-lying strip of land, flooding a low-lying strip of land by the sea. This can be a result of a rise of sea level at continental margins like the Gulf of Carpentaria, Australia. Conversely, gulf can be formed where the land surface is depressed and warped downward. Low-lying regions are sometimes down drops sections of the earth crust. Gulfs which occupy such tectonic depressions include Gulf of California and Persian Gulf. Where the Gulf is very endorse, a strait may link to the ocean or sea. For example, Persian Gulf linked to the Gulf of Oman and the Arabian Sea by Strait of Hormuz. Gulf shape and configuration depends on the topography. Although rugged coastlines, Gulf can have very complex shapes, connect with more than one strait as well as other gulfs and feature islands. One such coastline is the southern coast of Chile, where the Andes mountain chain extend into the sea and there is no coastal plain. Its crinked pattern contrasts with sweeping bays and curving gulf in the Argentine coast. Reef and atolls. A reef is a rich rock just beneath the sea surface, sometimes exposed at low tides. Reefs are common in coastal areas where the wave action has eroded the land, but rocks below the wave zone remain relatively undisturbed. They pose a hazard to shipping since they lie at the level of shallower than depth of many vessels. Reefs are less common in the mid-ocean, although they occur around oceanic islands in the tropical zone, where the top layer consists mainly of living coral rather than rock. Ridges of rock called reefs or shoals can run 100 of meters yards out of the sea under the waves. Coral reefs are the result of growth of marine organisms called polyps, which secrete a hard outer skeleton of calcium carbonate which anchors them to the seabed. Living coral can survive only to the depth of about 60 meters, but great mass of carbonate rock can build up below as polyps die and leave behind their skeleton. The reef may act to trap fragments of shells, coral and coral sand, which are pulled up by wind and waves to form a coral island. Barrier reefs, such as Australia's Great Barrier Reef, occur some distance offshore, originating in shallow water at the time of low over sea levels. Fringing reefs lie near the shore. Many mid-ocean coral reefs have grown around volcanic island. When volcanic activity ceases, the volcanic island may gradually sink back to the ocean crust aided by erosive forces. As the island subsides, the living coral continues to grow upward, maintaining its position near to the sea surface. Eventually, the original island may have disappeared from the view altogether, but the circle fringe reefs remains, some of them well established enough to be islands in their own right. These collections of islands, often almost completely enclosing the location of the submerged volcano, are called atolls. Maldives in the Indian Ocean and the Tuamotu Island in French Polynesia contain many examples of coral atolls. Capes and headlands. Capes or headlands are coastline promontories which extend into the sea. A rugged coast will have many capes, but they can form anywhere. On the long, more uniform stretches of coast, capes are sometimes the cusps dividing two curved bays like Cape Fear in North California coast, so USA. Also on the east coast of USA, Cape Cod, shaped by strong ocean current which move sand along the coast. Constant refreshment keeps the strange shape headland from being washed away. Cape Shipusky in Russia, Kamchatka Peninsula, photographed from the Space Shuttle. Capes are commonly outcroppings of resistant rock. Along sometimes some coastlines, faults which lie at the right angles to shore can be exploited by the sea and widened. Where there are several types of rock along stretch of coast, the sea removes the softer materials, forming gentle bays, and harder rocks more slowly, so they can form headlands. Particular large or elongated capes are called peninsulas. Rocky headlands, because they are prominent features, are often important visual navigation aids. A good example is the Cape of Good Hope, South Africa, first sighted by Portuguese explorer Bartolomeu Dias in 1488. Cape Horn on Isla Hornos at the southern tip of Tierra del Fuego, Archipelago, is a similarly well-known cape. It was named by the Dutch navigator William Schouten, who named the headland Home after his birthplace when he sailed around it 1616. Both Cape Horn and the Cape of Good Hope are renowned for the stormy weather and rough seas which prevail there. Navigation of Cape Horn is particularly hazardous. A photograph from Space Shuttle, the coast of South Africa, arrow picks out the Cape of Good Hope. Cape Aquahas, the continent southmost point, is clearly visible just below it. Islands and archipelagos. Islands and archipelagos. Islands are areas of land that protrude above the surface of the sea, a lake or a river. Islands in the sea may be coastal or oceanic. Coastal islands are islands only thanks to today's sea level. Some are linked to the coast of causeway at the low tide. Similarly, sea levels are some 100 meters lower during the last ice age. Many of today's coastal islands were part of the mainland. Kefalonia is the largest of the Ionian islands of the west coast of Greece. The islands of Dalmatia in the Adriatic were the tops of parallel ridges, and the British Isles were connected to mainland Europe by dry land. Conversely, the fjords of Norway and New Zealand are glacier-cut valleys which were flooded as sea levels rise. A large collection of islands such as those in the Aegean Sea is called archipelago. The islands of Croatia's Dalmatian coastline were created when the coastal valleys were flooded as sea levels rose at the end of the Ice Age. Islands in the mid-ocean may be large fragments of continental crust, such as Madagascar or North and South Islands of New Zealand, or true oceanic islands such as Hawaii Island and the small scattered islands as Polynesia. Here the islands of Bahamas sit atop extensive carbonate platform just off the North American continent. The remote island of Kerguelen in the Indian Ocean is in fact just the tip of the large subsided continental fragment, the Kerguelen Plateau. Oceanic islands are volcanic in origin, rising from the oceanic crust as underwater volcanoes until they form an island when they reach the surface. Extinct volcanoes often gradually subside, but the tropical waters, they can leave behind a ring of living coral which forms the coral island or atoll. peninsulas jutting out from land into water. Peninsulas are easily recognizable. They tend to be longer and narrower than capes or headlands. They vary in size and can be seen at continental and regional scales. They can also exist as local features and can comprise as very slender strip of land just a few kilometers across. Many peninsulas are not created as such, but are simply elevated parts of the Earth's crust, which, because the sea embrace the surrounding area, form a limb which sticks out. They may be part of mountain chain or upland. Locally, peninsulas can be formed by erosion, wave action on section of coast can wear away and remove soft rock, harder, often jagged looking outcrops of rocks are more gradually eroded and protrude. If the headland is long and narrow, it's called a peninsula. Large continental scale peninsula include Arabian Peninsula and the Iberian Peninsula, Spain and Portugal. These have more irregular shapes and though not very elongated. They are joined to a larger land masses by a slightly narrower neck. Other large peninsulas include Kamchatka Peninsula in Russia, the Florida Peninsula in USA, the Peninsula de Ungava in Canada. Here the Florida Peninsula seen from space. Undersea features. Far from being featureless, many parts of the seabed display more dramatic relief than the land surface. Ocean trenches around the Pacific plunge to depth more than 10,000 meters. 3D view of Bering Sea shows shallow waters of the continental shelf between Alaska and Asia. Deep Aleutian Trench and adjacent land arc with Kamchatka Peninsula on the horizon. The largest mountain on Earth is volcano Mount Kea, Hawaii, which rises 9,000 meters, 24 feet from its base on the floor of the Pacific Ocean. Many more volcanoes rise from the ocean floor but do not reach the surface. These are called seamounts. Guyot is a flat-topped seamount. Volcanoes of the Hawaii island chain rise up 9,000 meters from the ocean floor. The continents are fringed by relatively shallow areas known as continental shelf, lying up to 300 meters, 820 feet below the sea surface. At times the past, when sea levels were lower, large parts of the continental shelf would have been dry land, home for long period for plants and animals. At the edge of the continental shelf, the continental slope leads down to the ocean floor in most places below 2,000 meters, 5,460 feet. Continental shelf of northwest Europe extend beyond the British Isles. Much of the deep ocean consists of flattest places on the earth, the abyssal plains. These plains are punctuated by sea mounts, ridges, plateau, fracture zones, and deep trenches. Spreading ridges run across sea basins, marking the location where the Earth tectonic plates are moving apart, diverging. The ocean trenches show where plates are meeting, converging, with the oceanic crust sinking down under the adjacent area of continental crust. Icelandic straddles the mid-Atlantic ridge, shown in red. The mid-Atlantic ridge breaks through the sea surface at the island of Iceland, while the deepest part of the ocean is in the Mariana Trench, which reaches depth of 11,034 meters, 30,000 feet. Long fracture zones extend from mid-ocean ridges as part of the plate move at the different speeds. Very many fractures run out from the steep mid-Atlantic ridge, while several long fractures can be seen running through Pacific from the East Pacific rise. Seamounts. Seamounts is a mountain formed by volcanic activity rising at least 100 meters, 2,730 feet from the surrounding seafloor. Smaller underwater hills are called sea knolls, while flat-topped seamounts are known as goyots. Seamounts are completely submerged structures. If they are built by ongoing volcanism to protrude above the surface, they become islands. Though particularly common in Pacific, they are very widespread. Ocean surroundings surveys have revealed thousands of seamounts. It's thought worldwide that there could be as many as 20,000 of them. Simulated perspective view of Pacific Ocean Hawaiian ridge looking northwest towards the top of the image. The Empire seamounts are visible. Seamounts can occur in isolation or in clusters, but it is quite common to find them in chains. The most notable seamount chains are found in Pacific. These have a northwesterly trend and are typically associated with fractures which cross-cut the ocean floor. Among the longest seamount chains are those on Hawaiian Ridge and Emperor Seamount chain, which runs northward from the western extremity of the Hawaiian Ridge. Rocks retrieved from seamounts are said to be microcrystalline or glassy. They comprise a type of basaltic rock produced at mid-ocean ridges. Over time, a thin layer of marine sediment accumulates, blanketing the volcanic materials. Seamounts are not purely geological interest. They attract the attention of biologists for a wide variety of marine life which thrive on or around marine mountains. Deep is a deep underwater valley. Sometimes the word deep is used to describe the underwater canyons which cut across the continental shelf. A sonar images of the seafloor, and these look just like rivers on land. Some submarine canyons like These are thought to have formed by rivers but were merged by sea level rise. Simulated perspective view of a Pacific flow looking northeastward along the Mariana Trench. Generally through deep sea or oceanic trenches, they are narrow and have steep side and depths above about 7,000 to 11,000 meters, 19,000 to 30,000 feet. Deepest oceanic trench is Pacific Ocean Mariana Trench. Northwest of the Philippines is part of the very long trench which along east coast of Japan toward Kamchatka in the North Pacific. The Mariana Trench's deepest point, called Challenger Deep, lies 11,034 meters, 30,000 feet below the sea level. The submarine canyon in the sea floor of Monterey Bay, California. Running parallel to island arcs and mountain ranges, most of the Earth's deep trenches are found in the Pacific, having formed at the edge of the Pacific plate. Oceanic trenches are formed by subduction, where one of the Earth's tectonic plates move underneath another. For example, off the coast of South America, the Pacific plate is being pushed underneath the South American plate. It is bent downwards and become incorporated into Earth's crust. As the plate drawn downward, it takes material with it, producing very deep submarine valley. In the Atlantic Ocean, deeps are found in parallel with island arcs. In the Caribbean, there is a Puerto Rico Trench, and in Southern Ocean is South Sandwich Trench. These are associated with the subduction of smaller Caribbean and Scotia plates.